Contrary to REST API, you would have noticed that if you want to get, for example, a user details in the user endpoint, if you call the /users, you might not want to get the username, but you get the user picture, the user description, and user likes and comments and all those things. But with GraphQL, you just have to specify, okay, I just want the username, and it just returns you the JSON file of just the username, which is actually great. So the second reason why we should use GraphQL is because of the reduce and round trip. So what does this mean? In REST, for example, so if you want to get the user comment in REST, first of all, you might have to query the endpoint to get the user ID, then another to get the user post, then get the user post ID and get the comment for that post, right? But with GraphQL, all you just have to do is just call a single endpoint and just pass in, okay, I just want comment, and it will just return you the comment of that particular user. Easy peasy. Then GraphQL has something called deprecation because it works on, it has something called schema.graphql, which you will see in a minute. Because of that, the backend developer or whoever is developing the GraphQL server can just annotate a particular field as deprecated, and while you are in your IDE, during compile time, you'll be able to see whether a field is deprecated or not. So you don't have to wait until runtime to check, which is actually good. And yeah, lastly, there's something called introspection in GraphQL. So what introspection means is that it allows you to see all the queries that a GraphQL allows, all the fields that it allows, even before you even make any query, right? So it will prevent you from calling a particular field, right, on runtime and to get like 404, like something is not found. Yeah. So you can get all that. So you know what the query accepts even before you start. Some few GraphQL concepts to note. First is the schema. So the schema is the structure of the GraphQL file. It's like a skeleton of the entire GraphQL project. It contains things like a query, the mutation, and the subscription, and also the data type that it supports, like the string, the int, and the boolean. Second important GraphQL concept is the query. So query are basically like get for REST APIs. So with query, you can just call the endpoint to just get a particular result, maybe get the user or get the comment or something like that. Then mutation are like post twin, right, in REST APIs. So with mutation, you can basically just post, right, to the endpoint, post the data that you need. Fragments, yeah. So this is actually a very important concept that you will use in GraphQL. So fragments are basically like reusable piece of query syntax, so that it just helps you to reuse the function calls that you need in your GraphQL. We'll see how all this works in a minute. Oops, I skipped. So using GraphQL in your Flutter app, originally, if you want to do it by yourself, you have to think of things like the query, the mutation, the subscription, and displaying the data in your widget. But luckily, there's a package that I found which actually does all this for you. So enter Ferry. So Ferry is the name of the package. So what is Ferry? This is from the official documentation. Ferry is a highly productive, fully featured, extensible GraphQL client for Flutter and Dart. Some key features of Ferry. One, Ferry is strongly typed, meaning that it gives you that compile time advantage, right? You don't have to wait for runtime before you know that a string is actually an int, or an int is actually a double, and your outbreak, right? The second thing is pagination. I'm sure many of you would have done pagination before. So Ferry has an easy way for you to paginate your data. Then, of course, if Ferry is built for Flutter, it just has to have a widget. So they built a widget for it, it's called the operation widget. We'll see how that works. How to use Ferry. So the first thing is to, as with all packages in Flutter, add your dependencies, your prospect.yaml. So there are a couple of dependencies that you would have to add, to be honest. One is the Ferry package, which contains the client. Then the Ferry Flutter, so this contains the GraphQL operation widget. Then the GraphQL HTTP link, right? So with every GraphQL, you will need an HTTP link. So this helps you make HTTP requests to the GraphQL server. Then, yeah, Ferry does code generation for you. So you will need your normal build runner and Ferry code generator. Yeah. So after you've added all these dependencies to your prospect.yaml, the second thing is to add your schema.graphql to any location under the lib folder. As you can see there, I have my schema.graphql under the lib folder, under another folder called playferry. It's fine to put it anywhere you want, but it just has to be under the lib folder. Yeah, and with GraphQL, the schema is like the holy grail of GraphQL, right? So you just have to have a schema. Without that, you can't really do much. Now, if you're working with a team and you have a backend developer, the backend developer will likely give you the schema, right? So you just import that to your code, right? But should in case you are working with a public API and you don't have access to the backend developer and you can't find the schema anywhere, there's a tool that allows you to just grab the schema with the endpoint of the GraphQL. So the tool is get GraphQL schema. I've actually found it useful because sometimes I just want to play with public API, maybe Pokemon API, right? And I don't know where the schema is. So this just helps me to get the schema. So the first thing we'll need to do is to install the tool with npm install. Then we'll run this command, get GraphQL schema, then the endpoint of the GraphQL, then the location where we want our schema to be. Now, the third thing we'll need to add, if we want to use Ferry, is the build.yaml. So from the official documentation, Ferry says we'll need this build.yaml so that the Ferry will be able to locate our schema.graphql and know where it is in the project. Now, you see something called your package name. Yeah, so you have to replace that with your app package name for it to work. Then the third thing is to add your .graphql files. So these .graphql files just contains your queries, right? Your queries, your mutations, your subscription. Then finally, an example of a query is this. So everything is actually included in your schema, and the backend guy will likely just tell you what query to use. But should in case it does not, this is the structure of a query. The first thing is to write the query keyword, then the name of the query. So not really the name of the query, so the name that you want the query to be. Then to-dos is the actual query name that is coming from the backend. Then ID and title is what it returns, right? So if you make this query, right, it will only return the ID and title, nothing more, nothing less, which is great. Yeah, so finally, it's now time to run our build runner. So when we run our build runner, Ferry actually generates a couple of files for us. If we see this, for example, user to-dos.var. So these just the variables that we will need. So should in case your query has things like an ID, like you have to pass an ID or you have to pass a particular variables. So this handles that. Then user to do does requests, handles the actual request that you'll be sending to your backend. User to do's data is actually the data that will be coming back from the backend. Yeah, so Ferry helps you to serialize that. So how do you finally then use everything? Yeah, so I just created this dummy request, right? So the first thing is to create your link. I remember I talked about the HTTP link, which will be used to make a connection to the GraphQL schema. So inside the HTTP link, you pass the HTTP endpoint, yeah, so the GraphQL endpoint. Then if you have any headers, you also pass that. The next query requires that we pass the link to the client, right? Then we call client.request. So client.request, then the name of the request. Now, how do you know what request you actually pass? Ferry has a convention, right, on how they name the requests. So the first thing is that it actually starts with G. So this G represents GraphQL, then the name of the query, user to do, then followed by REQ, which is called the request, right? So you can name your request anything. For example, if I had named this request maybe like get to do, it would be G gets to do, then REQ, which is the request. Now, client.request returns a string, so you can just call the .listen on it and get the data inside of it. Yeah, passing variables to the query. We'll need to pass variables. For example, if we want to get a particular to-do in a to-do app, we'll need to pass like a primary key, like the ID of that to-do. So this is a screenshot from Azura. Azura is a website where you can just play around with GraphQL. If you check, yeah, if you see this is the structure of a query. So the name of the query is to-dos by primary key. Then we are passing in the ID, and I'm just returning the ID, and it's public. So this is the structure of the response here. Now, how do we do this with GraphQL? I mean, with Ferry. So the first thing is to write our query, then the name that we want to give our query. I called it get to do. Then we'll create a variable, and what is the variable type. Then the actual name of the query, to do by pk, then pass the ID. Next, what do I want to return? I want to return the ID, I want to return the title, and it's public. Now, translating this into code, bear in mind that, so each time you create a new query, you need to run the Flutter, you need to run the build runner, right? So how do we use this? Yeah, like I said before, your link, your client, then you call the client.request, and you pass in the name of the request, G gets to do, then REQ. Then now, every request from Ferry returns, every request from Ferry has a builder function. So this builder function allows us to access or to pass our variables to our particular request. Now, you can see this b.var. So the VARS is just the variables. So we use the cascade notation in that. b.vars, then the name of the variable that we're giving it. So remember, I gave it pk. Yeah. Then the actual primary key value, which is 571. Then I'll call .listen on it, which actually gives me back the response that I want. Now, next thing is the mutation. So, like I said, mutation is basically like a post request, right, in REST. So how do we do that? Yeah, it's basically similar to the query. So we write mutation, then the actual name of the mutation, insert to do, then whatever it accepts. Next, we'll now write what we actually want our mutation to return. How do we represent this in Ferry, in our IDE? Firstly, we'll write the mutation keyword, then whatever name we want to give that particular mutation, then pass in the variable and whatever we want to return. So you would notice that I'm passing in a list of to-do insert inputs. Now, this to-do insert inputs is a model that is coming from schema, which the backend developer has already created. I'm glad I did. So I created a screenshot for the schema.graphql. So this insert to-dos mutation on line 75, so you see object. So this object takes in a list of to-dos insert input. So this is how you know that, okay, this mutation actually takes in this kind of parameter. Now, this to-dos insert input actually takes in is public and title, right? So that's why you see here, this actually takes in an object of is public and title. So, and you will know all that just by looking at the schema. How do we use this? It's the same thing, create your link, create your client, but you don't always have to create the link and client. You can just use dependency injection to do it. I just put everything in one place so that for this demo, but please don't do this. This is bad. Yeah. So create your link, create your client, then call the client .request, pass in your request, then b ... variables, and what's the name of the variable to do model. Then we know that this takes in a list of to-dos insert input. So you can just basically call the add all method, then pass in to-dos insert input. Now this one in turn takes in some extra variables like title and is public, yeah. So we pass it in that way, then we can call .listen on it and we get our data from there. Yeah, of course, from the examples that I've been given, and you'll notice that I've just been using the print statement to print out the variables. In a real world app, you definitely not do that. Yeah, you want to display your results on the user interface. Next is the operation widget. So this widget is from the very package itself. It helps us to call the request and also to display the results on our UI. How do we use it? Right? So this operation widget takes in three main things. First, the client, then second, the operation request, then third, the builder. So this builder has something called response, which you can use to check if there's any errors or if it is loading or whenever we have data. So to use this in your app, I said you pass the client. The best thing to do is to use dependency injection to do that, right, for code readability. Now, how many of you has used Get It before? The package. Oh, just one person. Okay, two people. Okay. I'm sorry, this is not a Get It session, but I'll just, yeah. So the first thing to do if you want to use Get It, I don't know if I should go deep into it. So what I did basically is just create a client.dat, which will actually return my client, right? Then the next thing, I'm just registering my clients in setup DI. Now finally, on line 32, I can just call getit.i.client, then just pass that to my UI, which is actually cleaner than writing the whole link and whatnot directly inside the widget. So now, yeah. So if we come to this page, since there's an operation request and there's a particular request here, when you come to this page, the request just runs automatically, right? So inside this builder, you can basically check if response is not equals to null, then check if it is loading. If it is loading, show your loading bar. Then if it is not, then probably have data, then just show the list view.builder with your data. So this is similar to the future builder, actually. Yeah. Then the response also has something called GraphQL errors. So should in case there's any errors, you can get it from there. Yep. I'm sure some of you might be wondering, I mentioned that immediately you come to this page, it just runs. But that's not always the case, right? There are sometimes we'll be building our app and we want the user to click on the button first before an operation actually executes. So Ferry thought of that, and Ferry gave us a particular method called execute on listen. So you pass this to your request. Execute on listen is equals to false, so that whenever the user comes to this page, the request won't run automatically. Now, how then do we now run the request? The client has a method called request controller, which basically controls all your requests. So you call client.requestcontroller.add that particular request. So once the user clicks on the run button, for example, this just executes, and your results will be displayed on the UI. I'm coming to the end of this session very soon. So there's some extras that I wanted to talk about. So for example, comments. How do we write comments in GraphQL? We just basically use the hash keyword, then write our comments. I'm sure many of us are used to the /, like double /, but I think there's a programming language that uses this hash as a comment. I think I've seen, well, I don't know. But in GraphQL, you just use the hash key, right, and you write a comment. Now fragment, so this fragment is very important. Because if you're writing GraphQL, you find yourself reusing a lot of response, right? So sometimes, you might always want to return the ID and the title, right? But you don't always want to be adding ID and title every time. So the best thing is just to create a fragment, right? Then just pass that to it with the triple dots, dot to the fragment. So you know that anytime you call to-dos by PK, you are definitely going to get your ID, your title, and it's public. Next, I found it useful to install the GraphQL plugin in Android Studio. I'm sure many of you use VS Code, and I'm sure, to be honest, I didn't even check, but I'm sure there will definitely be a GraphQL plugin in VS Code. So this plugin just gives you advantage of autocomplete when writing your GraphQL files, and it just give you some syntactic sugar. Like it colors your queries and the name of the queries, so you can differentiate from what is what. And finally, these are the links if you want to read about Ferry. So that's the Ferry link, the Ferry package, then the get schema package that I talked about, then Azure GraphQL playground. So this just helps you to just play around the GraphQL, mess around with it, try your hands on it, write different queries in different forms, and see the kind of data that you will get back. And if you like my talk, those are my socials. You can decide to follow me. I follow back. So that's it for me. Does anyone have any questions? I should have turned this into a single QR code. My bad. It's fine. Does anyone have any question on Ferry or GraphQL? Silence is golden.
Okay. This question has to do. I know Ferry is a package, right? And it's very useful based on what you have explained so far. So, but situation where in an enterprise project where you this still depends on build runner, because you have to run build runner for code generations and the rest. So is there a way we can avoid code generation, maybe by not using maybe if there's another package that gives us, have you compared like one or two packages that do the same thing?
To be honest, I wish we not have to use the build runner all the time, because it generates a couple of files, but I think that's a good trade-off, because for the other GraphQL packages that I've seen, right, you'll be the one to write your query by yourself as a string, and that can easily go wrong because it's just a string, right? So Ferry actually helps you turn your schema to a Dart code, and also the variables also, so you can easily use it. I think that's the only thing we'll have to deal with when using Ferry, right? But the only thing you can do is just find a way to group your generated files into one folder, right? So put all your queries, all your .graph files in one folder. So whenever it generates, it just generates inside that folder, right? So it doesn't spread to other classes. Yeah. But that's a good question, yeah.
Thank you for the answer. It really explained my question. So another question is, has to do with the security. So I could recollect that when you started, you talked about RESTful to GraphQL. So you mentioned the advantage, the merit of GraphQL to RESTful. So can you expatiate further why GraphQL is more secure to RESTful API?
So to be honest, it's just the same concept, right? With GraphQL, you are still going to be making HTTP requests, right? Just as you make HTTP requests to a REST endpoint, and you can safeguard it by using, I think I showed it here. So your backend developer can always safeguard your GraphQL request by forcing you to pass an authorization key, just as you do in REST, right? Yeah. So any headers you want to pass in REST for security, you can also pass this in GraphQL. Yeah. Yeah, but that's a good question.
Okay. So for REST, so if you want to upload the media file and you have multi-paths, right? So do we have the similar function in?
Yes, we do. So for example, there's an HTTP link. There's also a variation of a media link that you can use to upload your files, an image file or a video file or anything. Also, there's even something called a WebSocket link, and I can use it for real-time updates. Yeah. So GraphQL has a couple of links that you can use. To be fair, when I was creating this slide, I actually asked myself that question, and I came across a particular article by some guy called Adam, which actually talks about it. I can show you the article after my session. Yeah. Thank you. Is there any question? Yep.
Yeah. So I noticed that you mentioned anything concerning error handling using Ferry. So is it a case of Ferry doesn't offer error handling for GraphQL, or is there a way to do error handling in GraphQL? I'm sorry, in using Ferry.
Using Ferry, yeah. So Ferry actually handles, I didn't just add it here, so Ferry actually gives us error handling. So in the response, where did you go there? Right. Yeah. So this response object, which is an operation and response, it actually has a method called GraphQL errors, right? So you can just do response.GraphQL errors, like if it's equals to null, then you are sure that you have no errors. But otherwise, if it's not equals to null, you can basically just display the error on the screen. Yeah. So Ferry has a GraphQL errors method that you can use.
Thank you for the beautiful talk. I know I came in when you talk, but I just want to ask, comparing the developer experience with using like this package, because like you said, the big runner can be nice sometimes, like you try normally as well. So I just want to ask you, have you tried to compare maybe using GraphQL and open API, so that you can actually automate package, just like you do here. But in terms of comparing their developer experience, basically, because with Open API, which is REST API, I can just generate just the way the Swagger URL and to generate the package for you. And honestly, that's what I just need to. I could just keep calling the package. But now I'm seeing that you have to write something schema dot. I have to probably edit it again. Then you have now run some commands. So just want to, is it probably maybe there are two approaches. Maybe the one you probably just use the package and it generates package for you. I don't know, but what I'm saying, I feel like it's, I don't know. But I know it depends on the API, if it's API is in fact REST API or in GraphQL. But I just want to know in terms of the developer experience for the mobile developer, which is best. Going to this route or Swagger UI.
So for the company that I've worked for, I noticed that the schema of GraphQL is always already established, right? We rarely have to edit that, and even the queries and the mutation is already given to you by the by your backend. So all you just need to do is just add that to your folder and run Flutter build runner, right? But should in case there's maybe a breaking change and the backend developer wants to add something new, then you might have to edit your query, right? But that doesn't happen often, actually, yeah. Yeah. But I get where you're coming from. It's still the issue of the build runner, right? I think this is just a trade-off. Yeah. So if we want compile time safety, right? If we want the beauty of autocomplete and all that, we would have to deal with the build runner issue. But it's not so bad, to be honest. Yeah.
So maybe another question that could come out from that is there a way to actually automate this generation? Because let's say when there's any breaking change, there's an automated process that's run, and maybe the developer probably just run an automated script to get the updated schema. I don't know, maybe there's anything like that.
So with build runner has something called watch. So that you don't always have to run the request again, right? So if you just edit your query, it will just automatically run it for you in the background, right? Yeah. So that can help.
Yeah. So in addition to that, another advantage of, another thing we can do is to specify whatever you want to run your build runner. So build runner helps us to, you can specify the file that you want to run. So instead of build runner to generate the whole project again, like everything you want to do, there are places where we require build runner to generate code, right? Sometimes if you are using Flutter block and use freeze. So you still need to generate sense. So you can specify the file that you want build runner to generate for you, rather than going through all the stress of build runner code.
Yeah, and just use the watch parameter so that you don't have to write the entire Flutter build runner build, and all those crap, does anyone have any question? Okay.
Yeah, so when you are talking about REST APIs, right, there's this concept of interceptors. So how does it work here? Is it similar or is it entirely different? So you need like spin off custom interceptors, maybe to your request or mutations or queries. How does it work here?
Yeah. So the HTTP link, like I said, the HTTP link also has an interceptor parameter that you can actually use. So this HTTP link is just make HTTP request to your server. So everything that you can do with REST originally, you can also do it with this.
Does Ferry support like a local cache at all? So if, for instance, if you've got a mutation that you know updates data, can you change that data without re-requesting the query?
So you're talking about caching, right?
Yeah, does it have like a local model of the query that you can update?
Yes, so with that, so you can actually pass a cache. So it depends on the kind of cache that you use. If you use something like Hive store, right? You can always pass that cache to the client and make updates to that. Is that what you're talking about?
I come from the web world, but
Okay.
with Apollo, you have like a normalized cache and you can update. If you have a mutation, you can update update the response, so update your query data depending on the mutation response, and have the UI update without needing to do another HTTP request.
I'm not sure I get your question. Yeah.
Yeah,
You?
with that thing, it might be the same as the local storage like you mentioned, like
Okay.
using Hive or any other like Drake or any other storage procedures. So once you get the response, you hash it inside and you can read it later.
Yes. I mean, it just has to be the same, right? And the same way it runs on the web. So if you have your Hive store or you have your, I think it also supports shared preference and SQLite,
I
right?
guess, let's give an example. If you've got a query for getting your to-dos, and you do a mutation to add a to-do, is it possible to add to the local version of the to-dos without re-requesting to-dos?
Oh yeah. Yes. So you can actually do that with the client dot request controller, right? If you actually, let me see where I actually use that in the operational request. Yeah. So with this, you can basically update the local copy of your request. So once you have created your request once, you can basically reuse it over and over again with clients does request controller does add, then passing in that same request, right? Yeah, and it just basically adds that to the request. So you can do that with the request controller. Any other question? Yeah, no question. All right. Yeah, thank you very much, guys.
So, can we clap for him again, please? So now that Franklin is done, there's something I want to actually just draw. He wrote a list of packages on the link. So we are throwing out £50 for anybody.
Oh, really?
Yeah. For anybody that can tell what these 4 packages are used for. No, not Yeah, what for? I mean, you could just try. Maybe if you get more than any other person, you could get money.
Optimize for documentation, that's on the very.
Please, can you start?
Is it linked to packages?
So these are packages, right?
So basically linked, not the package.
Oh, the packages.
It's only one package that is actually there.
This one, actually two.
Yes.
Yes, these 2 packages, if you can say what these packages are used for. Hold on. Sorry, just hold on. Who wants to speak?
I want to speak.
So we'll entertain the 3 of you.
Oh,
Please just stand and talk.
Alright,
Please stand. Thank you.
thank you. So basically the ferry docs is where you get to know how to
No, the ferry package and the get schema package.
Alright.
No, hold on. The ferry package and the get schema package, just those 2.
Okay.
Yeah.
The ferry package is actually the main implementation of how to use GraphQL in Flutter, whereby the get schema package is if you already have a GraphQL API and you can quickly use that to convert the GraphQL to DAX code, so I can speak to you. But the ferry package, now this is where things get complicated, is the ferry package is basically the one that actually builds whatever the get package, get schema package returns and probably run the period likes.
Okay. Is it right?
It's okay for the ferry package, but that get schema package was not on 100%.
Yes.
Just to answer the question, right? Just like the name gets GraphQL schema, what it does is just if you give it a URL, it just gives you the schema and you can actually get the actual schema without having to write it again for it. So that's anything you get.
And the ferry package.
And the ferry package.
I mean, the very package allows you to abstract GraphQL in your code. It does mutation, it does queries, and it does return.
Yes, yes, let's go. Alright, so we have Dan Steve for £50 and goodness, stage fright, sorry. That's why I don't remember your name.
Oh,
Kenny.
Ade. Ah, my name?
Yeah.
Ade.
Ade. So we have Dan Steve for £50 and Ade for £25. We've come to the end of this session. There are pizzas, drinks, just network.
Nice
You say no,
one.